Hello and welcome. This is the latest video of my series Basics of Life or Life in the Universe. And today we're wondering about likely and unlikely places for life in the universe. So this is more or less an extension of the Habitable Zones video I did earlier. And you can see here already something that I'm going to mention during the video. So the three topics that we're going to shortly mention today is what makes the Earth special, and following from that, the anthropic principle and the saying by Enrico Fermis. And then in the end we'll talk about galactic habitable zones, which is the suggestive, corresponds to the suggestive image in the beginning. What makes the Earth special? Sure, I didn't mention everything that makes the Earth special, but some important point of our green planet. The atmosphere turned from I called it conventional nitrogen CO2 atmosphere into a very much O2 rich atmosphere. This has been done by life, but this is a factor that actually helps life to be sustainable. Because once you have oxygen, you have 30 times more energy, and we wouldn't be possible. And if it were possible, we would walk very slowly if we didn't have oxygen to breathe. The atmosphere thinned as the sun grew hotter. This is something that people connect with the Gaia hypothesis. So in a way, it looks as if the Earth reacted to the hotter sun by putting away clothes, to sort of by thinning the atmosphere. We're more or less in the middle of the habitable zone of our sun. Actually, we're a bit going towards the inside of the middle. So the ideal Earth would be 109% of the distance of the sun it is now. There are lots of water. We have talked about this in an earlier video, and it's still a bit enigmatic why we have so much water. The only body that has more water in our solar system is Europa, about which we also talked in an earlier video. Plate tectonics are very important. You think, yeah, it's making new crust, but it's not only making new crust, it's making a new atmosphere, the plate tectonics. So, and you can look to Mars, which I also mentioned in an earlier video. What happens if you don't have plate tectonics? Then after a while the planet goes dead and you can't keep an atmosphere. In a way, plate tectonics are also a symptom of a hot core, and this is also something that has influence on the sustainability of life on a planet, which is also a problem that Mars has, because its core has cooled down too much, whereas the Earth's core is still quite hot. We have a large moon, which also drags on the Earth, but it makes the Earth's axis more stable, and it also protects us to a certain degree from impacts of meteorites. So it is not fully clear to what degree the moon helped to keep us on the Earth, but it's probably rather helping. And in the inner solar system, the Earth is the only planet that has a large moon. But the Earth has also most mass of the 4 inner planets, so it can also keep a moon. The solar system is kind of divided in 2 parts, the large planets outside and the small planets inside. And this turns out to be very special. Normally, suns have either large planets or small planets. So it is not clear if this is an advantage or disadvantage. It could have destroyed the inner planets completely. But now the whole system has stabilized. The large planets probably help to protect us from things coming from outside, especially comets, which are very fast and very dangerous if they collide with the Earth. But also small planetoids or asteroids. The solar system has almost circular orbits. A bit enough of an exception is Mercury. And the planets are in a dense package. So the whole system is quite stable, but it has not been as stable in the past, as we know with the Nice model and these things that were connected with the late heavy bombardment. But once the late heavy bombardment was over, the solar system was quite stable. The Sun is a 3rd generation star of the spectral type G2V or G25. And being a 3rd generation star is for sure important, because otherwise we won't have carbon and iron and lots of oxygen and this kind of thing. We would have hydrogen and helium, but you can't build structures with hydrogen and helium alone. So if you look for life, you don't only have to look for water, you also have to look for metals in an astronomical sense, so heavier elements. And without these heavier elements, it's hard to make life. That's also the case for the huge planets, because they consist mainly of gases. Although they may have some metals, but somewhere inside where it's so hot that life may be difficult, also with the pressure. A supernova has happened shortly before the solar system started. It may even have triggered the solar system, the formation of the solar system. But after that, the environment was relatively quiet. A close-by supernova could destroy us anytime, the life. Some fast-moving stars are dropping by from time to time and then vanish in the void of the galaxy. It's not clear if they help or are a threat. As long as they're not explode in the vicinity of the Sun, they're probably not a big problem. They may trigger comets coming inside, which can be a bad thing. Our experience with that is not very good yet, because we overview only a very short time. But we know that this happens. There are fast stars coming by. And we're a bit out in the spiral galaxy, not in the center. We will talk about this in a minute. All of this makes the Earth special. So the question is, does the Earth have to be as special to harbor life? The point is, we don't have statistics, because we have just one observation, and statistics needs several observations. And our methods are not good enough to find life on extrasolar planets yet. We're now able to look for atmospheres on extrasolar planets, which is already quite good as compared to 20 years ago. And these methods will improve for sure. Telescopes grow larger and the resolution better. We can now see some planets not as maybe 4 pixels or so, not as a single pixel. That's already an advantage. The anthropic principle is just a way to pass by statistics and say, hey, listen, we have one planet where it worked. This is a sign that it could work in other planets as well. But of course, as I just explained to you, this is not an argument. Because, yeah, we exist, but we could be alone. Nobody. As soon as we don't find other life, we don't have any proof that we're not alone. The kind of contrary view was Enrico Fermi that said, based on this formula that says in the galaxy we should have several planets that are able to have not only life but also technically able life. Enrico Fermi said, but where are they? Because we're not bursting with evidence that other life came here or sent us signals or this kind of thing. Although not all the signals we received from the space we can understand, especially these radio signals. There are many arguments for that. Some say they don't wanna look for us because most planets inhabited by technically able people are dangerous and will start wars, so they don't want to do that. Some argue with the short-livedness of technical civilizations and say they did not live long enough to start long-term projects like visiting somebody far away from them, several light years or several tens of thousand light years or something. That's the funny thing, that we're talking just about our galaxy because it's kind of openly impossible to fly from one galaxy to the other, because it would take such a long time that the probability that something fatal happens to a spaceship is 1, basically, if you fly from one galaxy to the other. Energy going out, or just one crucial system not working, or several almost crucial systems interacting in a way that the whole system fails and everybody's dead, or even computers are dead and probes are not gonna reach anywhere. So the cost of traveling far within the galaxy is also very high. And I don't think that somebody will send probes to us before having talked to us. That's my interpretation. And there are also other interpretations. For example, there may not be so many and not so close to us. And they may be like us, maybe just have reached the ability to travel into space. So first they need some time to be experts in that before they come. This kind of thing. There are many explanations on many layers why they're not coming, but the argument of Enrico Fermi still stays, because one day they may come, maybe. And why haven't they done that earlier. And a general observation I wanted to share with you here is also be cautious with probabilities, because even if the Earth is very special, there can be other ways to be very special and produce lives. I can't tell you what these other ways are, but there are cumulative probabilities. So if you have a very large number of almost impossible events and you add them up, the resulting probability, cumulative probability, can still be quite reasonable. And this is something we can't handle with the data we have. And probably we will only be able if we start detecting life not one time but several times, and then study when is it possible to have single cell life, and when is it possible to have higher organisms in the sense of organizational complexity. These are some points of caution to viewing the Earth as very, very special. Then this slide luckily is a bit simpler than the two we just managed to get behind us. The galactic habitable zones. There are some arguments of where in the galaxy you find life and in which galaxy and where you won't. Star density shouldn't be too high, and this again is the supernova kills us argument. Not only supernovae are dangerous, but also pulsars and black holes and pulsars crashing together, this kind of very violent, energy-rich events. And if you look at the stars in our vicinity, I mean, amateur astronomers know them quite well. There are not too many dangerous stars in 2,000 light years around us, so we're relatively. I mean, people say Betelgeuse is gonna explode, but it's in a safe distance. Nothing's gonna harm us from that. But if there are huge stars or very massive stars in 20 parsecs around us or something, or 60 light years, 50 light years, that would be bad. The disk contains stars of a higher generation. I told you that the Sun is a third generation star, or it's certainly not the first generation star, as measured with the metals content in the solar system. So, for example, globular clusters where SETI sent messages in a couple of years ago, they're not good for life because they contain basically all first generation stars. And there may be planets, but probably not planets, terrestrial planets with carbon and iron. So life in our sense is probably not so likely there. Maybe there are other forms of life, but if they can grow technical enough to receive radio signals, we don't know. But the best guess to look for life, for technically developed life, is certainly not in globular clusters and not in elliptical galaxies either, and in spiral galaxies rather in the disk but not in the galactic halo. The metal in the planet is of course also important for the magnetic fields, and as we know from the Earth, magnetic fields protect the atmosphere, and the atmosphere protects the surface from getting deadly. So that's the two-layered defense system that the Earth has against the Sun. Other suns may be less devastating, but they may be less warm either. Also. So it being in the disk is good, but not too close to the center because there are too many supernovae. We can also extend our view to the group of galaxy where life can be built or not. We're also in a very special group of galaxy, which is a small group with just 2 large galaxies in it. And this is bad for the small galaxies, but it may be good for the large galaxies. In a way, the collision with the other large galaxy seems extremely unlikely, although we know that this is going to happen in 5 billion years or so. I don't understand the dynamics of the local group enough, but in a way it seems to me very unlikely that if you have 2 massive galaxies, they're gonna encounter each other. What is very likely is that they encounter the smaller galaxies. So smaller galaxies probably crash a lot more. They crash among each other, but they also crash with the large galaxies, which may be devastating, more devastating for the small galaxy than for the large galaxy. Why is it our galaxy crashes devastating? When they happen, there is massive star formation, which will be good to make more planets, but it will also disrupt existing planets again by the supernovae that are coming quite quickly after that. So after a couple of million years, the supernova start. And this is too short a time for life to develop. So as a summary, looking at the special Earth may bring us on the wrong track, because there may be also other special places in the universe. Many factors play a role, but it's never fully clear how they add up or how they interact. There are trade-offs, for example, which is factors that are good and bad at the same time, as I just cited with the star formation, or also ultraviolet. It can be good for a planet in the beginning, but it's worse after a while when life already is there. Or flare stars, they can also trigger life, but they can also destroy life. The same for interstellar matter. It's good to have gas and dust from earlier supernovae to build carbon and iron-rich planets. But it can be also too much, because more massive stars can build and go supernova. And something I also wanted to mention is that initiating a process and keeping the process stable doesn't have to be the same thing, which speaks for transport or for development. And on the Earth, we clearly have seen this development when it comes to the atmosphere. Thick CO2 atmosphere has turned into a thin O2 nitrogen atmosphere. This kind of thing, but it could also be good to transport life, maybe from one planet to the other. And this can even be done with microbes, or higher animals may be able to board a spacecraft and fly. But the question is always, can you transport a relevant number of subjects? And the relevant number of subjects is not 3 or 6, certainly. This can be seen in biology. They say if a species goes below 600 individuals, it may get lost sooner or later. So if you find a easier to live planet, you should have at least 600 individuals there to start a new population. Yeah, I wanted to make a short video, but I never succeed in doing short videos. I'm sorry about that. And this is my last slide. Stay curious and keep looking up. Thanks for the attention.